Hi there, it's Autumn. When I study computer vision, I felt like I understand convolution pretty well. It's taking the dot product of a kernel with the original image and produce a new value. So if I have a 555 convolutional kernel here, at first I will convolve it with this part of the image, and then it will produce a value for this pixel at this location, which is the center pixel of this area. And then I keep sliding the kernel across the image and produce new values for new pixel. And then this is the output image. But when I started to dabble into convolutional neural network, I felt like I didn't really understand anything because there are just so many numbers in one simple convolutional neural network that I found on some tutorials on the internet, like this one here. And when I do model.summary, it gives me a bunch of numbers that I also don't really understand. Let's break them down one by one. At first, let's focus on these two numbers. 555 is the size of our convolutional kernel, and 256 by 256 is the size of our input image. What is the shape of the output image that we will get after convolving our original image with this 555 filter? Well, we can do the math to calculate that. So, to get the dimension of our output, we will first take the input, subtract it by the size of the kernel, plus 2 times the padding, which we don't have any here for simplicity, and divide all of them by the stride. And then, lastly, plus 1. So in this example, our input has the size of 256 by 256, and our kernel has a size of 555, and we have no padding, and we're just sliding the kernel 1 pixel by 1 pixel like this. So the stride is 1 plus 1 at the end. So our output image would have the height and width of 252 by 252. And that is exactly what we got over here. Then what is the 16 here? That is the total number of layers we have in the third dimension, which will match the number of convolutional kernels that we specify here. Why is it that way? Well, it's because when we do convolution for the input image, we're actually doing it in a 3D way. So if you notice here, our input shape has a last dimension of 3, meaning that it is a color image. So the input is actually like this. If it's an RGB, then this is the red channel, this is the green channel, and this is the blue channel. And so as a result, the convolutional kernel we use is also a 3D one. And so every time we do convolution, we actually do it for the whole 555 by 3 block here. And when we dot these 3 layers of area here with these 3D convolutional kernel, we will get this pixel, only 1 pixel in 1 layer. And so the dimension of our output image is actually 252 by 252 by 1, not by 3, like the input and the kernel. And remember that we specify the number 16 here, which means that in this convolutional layer, we have 16 different convolutional kernels, 16 different 555 by 3 kernels. Let's say this is our first kernel, then our second kernel, let's give it a different color, will be this one. And so we will have the same input image. And so when we dot it with a different kernel, we're going to have a different output image, but they will have the same dimensions. So when we do this with 16 different kernels, we're gonna get 16 different 252 by 252 by 1 output image, and then we lay them all on top of each other, and eventually we'll get 252 by 252 by 16 as the final output from our first convolutional layer. Now let's look at the max pooling layer. So the input to the max pooling layer is the output of the previous convolutional layer, which is this thing over here. So what max pooling do is it will slide a 2 by 2 kernel across the entire image, and at each 2 by 2 area, it will select the max value in that area. For example, if this is the value of this area, then it will select 9 and make the whole area become just a pixel of 9 here. And then by the default parameter of max pooling, it will slide the kernel to here. So you can see that there's no overlapping between the places that we do the pooling on. And so if the value is like 8, 5, 10, 20, then 20 will be selected to be the value of the pixel here. And so how did they get this output shape? Well, it's using the same formula that we used before. So the value of the output will be the input subtracted by the kernel size, which is 2 by 2, and then plus 2 times padding, which is 0 here, and the stride is 2, not 1 like in the convolutional layer, because you can see in this area over here, when we slide the kernel across the image, we jump through 2 pixels to put our kernel here. So the stride is 2. And then plus 1 in the end. And the output we get has height and width of 126 by 126. And the third dimension has size of 16. Because we are doing the max pooling for each layer of the input, and so our output is also gonna have exactly the same third dimension with what we have in the input. You can use exactly the same math to calculate how we can get the output for the next convolutional layer and for the next max pooling layer. We see that the third dimension goes from 16 to 32 because we specify the number of kernels in the second convolutional layer to be 32. And in the flattened layer, what it does is it takes the output of the last pooling layer here, multiply them all together, because essentially it's flattening everything. Imagine you have a cube and of like a lot of pixels, and it is taking all these pixels and lining them up in one line. And so to do that, you just multiply the height by the width by the depth, which is gonna be this number. And that's why we have the output of the flattened layer like this. And this flattened layer will get passed into the dense layer, and that dense layer is gonna give us only one output in the end, which in the case of binary classification is usually the probability of an input image belonging to class 0 or class 1. I hope that helped, and please contact me if you have any thoughts or feedback, or if you notice anything that needs correction in this video. Have fun learning!